Okay, well, thank you everybody for sticking around this long. I really appreciate it. And I have to say that I've found a lot of the talks and a lot of the comments that I've heard so far today to be really fascinating. And I'm going to try to address some of the things that I've heard people say, see if I can say something about them in my talks too. This is a sort of a combination of my data and Stefan Lindeberg's data. As well as just some kind of thoughts as to what it might be or what of the many factors might be actually helping help show the paleo diet, is good for people with diabetes. I don't have the answers though, so bottom line. So we're going to talk a little bit about what are the goals of diet treatment in diabetes, and some of the paleo diet research results that we have and some of the comparison diets. And then again, a little bit about why might this be. So there's good data that suggests that if you have low fat, low carb, high fiber diet, exercise in people who have impaired glucose tolerance, and you also have weight loss, that you will help lower blood sugar levels and presumably lower insulin levels, especially if you believe the last speaker where low insulin levels is our goal. And so other things that have been shown to be helpful is for those people who tend to be round around the middle, optimizing waistline, not only decreasing what your blood sugars are, but how much sugar you take in and how much insulin, affecting other cardiovascular risk factors like high blood pressure and atherosclerosis. And then for diabetes especially, preventing the complications of diabetic disease, which are things like you can't see the nerves in your body are shot and your kidneys fail. So if you say, how well do therapies work, I like to use the Premier study because it was in sort of overweight, middle-aged women who had mild hypertension who were treated for 6 months. And the intervention group got a DASH-type, low-salt diet. They lost weight. They increased the amount of exercise. So if you had to say to yourself, what do we tell people to do? I mean, this is what we tell people to do. So then if you say to yourself, so how well did that work? Okay, in the Premier diet, yeah, their BMIs went down a little bit and their glucose improved a little bit. And their insulin levels went down a little tiny bit and their insulin sensitivity index improved compared to the control diet, where in the control diet, actually their insulin levels went up. So, yeah, if you say to yourself, what am I trying to do? So lower BMI, yeah. Lower insulin, yeah. Lower glucose, yeah. Does this treatment work? Yeah. But are the results very impressive? No, not even a little bit. And so then you wonder why it is that people don't seem to get very much out of diet, and we end up giving them pills all the time. It's because really diet isn't working all that great. So then you say to yourself, if you really want to give somebody a diet for their diabetes, what other options are there? And that's where we came to these studies with the paleo diet, where, like you can show, and actually, why don't I just show the results? So this was our study. Now, I work in a research center. So what that means is that we make all the food that we give to people. So they're not being told what to do. We have them come in, we figure out how many calories we need. We feed them exactly the diet we want them to eat. We make them bring back all the food that they didn't eat. We weigh them every day. We make sure that if they're losing weight, we feed them more calories. So in as much as you can control the things that you can control for diet research, we try to do that. So in our healthy volunteers, and these were healthy volunteers who were a little bit overweight, and in order to qualify for this study, they had to fail the exercise test. So we put them on a treadmill, and if they were at or below the average for their age and sex, then they were qualified for the study. And in these healthy people, otherwise healthy, after 2 weeks, okay, with no weight loss, because remember, we didn't let them lose weight, okay, what you can see is Do you guys see the, oh, here it is. No. Is there a laser pointer?
Yeah, it doesn't seem to.
No. Okay. So I'll just explain. So in the graph on the left, okay, what you can see is that the more the subjects followed the diet, which is the higher their urine potassium excretion was, okay, the greater the change in the amount of insulin. So the amount of insulin went down the more they followed the diet. And when you said to yourself, who are the people who got the most better? Like everybody got a little better, but the people who were insulin resistant were the ones who got the most better. And so that's actually what prompted us to do studies in people who had type 2 diabetes, is because the ones who were the most insulin resistant seemed to be the people who were doing the best. And this is Dr. Lindeberg's data. And in this study, they looked at people who had heart disease, so ischemic heart disease, which means their blood vessels are all clogged up with atherosclerotic plaques. And usually these people have high blood pressure, and oftentimes they're overweight. And when he put these people on the paleo diet, what he found, and this is the graph on the left, is that when they give people these glucose tests where you drink this glass of glucose and then you check to see what their blood sugar levels are, you could see that on the left, the ones who are on the paleo diet, their blood sugar levels didn't go up as high as the ones on the right, and the ones on the right are on a Mediterranean type diet. And when you looked at the total change in the amount of blood sugar over time when you have them drink this glass of sugar, then you could see that the Paleolithic group had much lower levels of glucose over time than the ones on the Mediterranean diet. And at the same time, and Dr. Lindeberg was looking at waist to hip circumference. So he's looking to see whether or not their waistline improved, and yes, they did. And then he did another study where he took people with type 2 diabetes and he switched them from one diet to another. And having tried to do a study like this, I am totally impressed that he got this many people to do this study for this period of time. This is amazingly difficult research to do. And what you can see is that the people on the Paleolithic diet, which are the round clear O's, okay, on the paleo diet, their hemoglobin A1Cs were lower, their HDL were higher. So HDL is the good cholesterol, was higher. Their triglycerides were lower. Their diastolic blood pressures went down. Their weights went down. So when they switched these people from one diet to another, they were able to find that, that these same people did better on the paleo diet than they did on this Mediterranean diet. And this is pretty amazing results because these people were not in a metabolic ward like the studies that I do. These people actually were just told what to do. Here's some instructions to follow. So the fact that they were able to show this at all with people who are out in the community who are just eating their food that they were making themselves over such a long period of time, really thought was very impressive. So we then went back, and again, we do studies where we make all the food for people, and then we follow them every day. Okay, so this is from our study in our diabetic patients, and what you could see is that in the purple is the paleo diet, and in the brown is the American Diabetes Association diet. And our American Diabetes Association diet was really a Mediterranean diet. And so these measures of glucose control, like fructosamine and fasting blood sugar and hemoglobin A1C, the little stars mean that was significant. And we did something called euglycemic hyperinsulinemic clamps, which is considered to be the gold standard by endocrinology doctors for looking at what's happening to the body's insulin and sugar requirements. And so the lower the M values, the worse you are. So none of our patients were very good. So they all got better. Both groups got better. The ADA diet got better and the paleo diet got better. But when we said to ourselves, so how did these people improve? And this is the graph on the right-hand side. So what you see on the bottom graph is that the people with the low M values, which is the pre-treatment M, the ones with the low M values were actually the ones who had their M values go up the most. And as a clinician and as a doctor who, my patients never do what I tell them to do. So if I have to spend energy trying to get people to do something, I want to ask myself, what's the group that I think is going to get the most results for all the energy that I'm putting in? Who should I concentrate on? And I think it's totally fascinating that, the people who are the worst are the ones that got the most better. And those are the people that you really want to help, okay? Not the ones who are sort of okay anyway, but the ones who are in terrible shape. Those are the people that you would really like to be able to help. And this is apparently what the paleo diet does in these people, is those are the people that improved the most. And and as a kidney doctor, I find that incredibly helpful because, diabetes is the #1 cause of kidney disease in the United States. So this is an amazing result. So far I've shown that, the paleo diets lower glucose and lower insulin, and really appear to do it better than the so-called regular diets that we use, the American Diabetes Association diets. And now I am going to go way out on a limb, and I'm going to talk about some of the reasons why these might possibly work. So that's the panda out there on the limb. And so there, I've heard a lot of people say, oh, it's the insulin levels, it's the leptin levels, it's the energy expenditure, it's the carbohydrates, it's where you get the carbohydrates from. I don't know the answer to that, but I would be amazed if it was just one thing. I mean, there's not very many things in the body where there's only one pathway that takes care of stuff. Most of the stuff that's in the body is redundant. There are many pathways. And so I'd be totally amazed if it was just one thing. It's more a question of perhaps like what's more important than, another. And that I don't think we have an answer to. So what I'm presenting here is really just some of the things, some of the possibilities that influence why one person might be more insulin sensitive or insulin resistant than another. And there's a long list here, and so I'll talk about some of them. So genetics. Okay. Some people are just predisposed to developing diabetes. We know that because diabetes runs in families. And at least some of it may have to do with where do you put the fat. So do you put the fat around the middle? Are you apple-shaped? Do you put the fat around your butt and your legs? So are you pear-shaped? Is it a question of what's happening to the signals inside the cell after they get past the insulin receptors that are in the cells? A lot of people talk about post-receptor insulin signaling changes and how that affects how the cell is able to use the sugar that gets in. Whether or not your blood pressure goes up when you eat a lot of salt. Okay? Some people, doesn't matter how much salt you eat, your blood pressure is not going to change at all. And other people, if you increase the amount of salt that you eat, your blood pressure will go way up. People whose blood pressures go up when you eat a lot of salt have a tendency to fall into that metabolic syndrome category. And this study showed that in the graphs on the left, as the amount of salt went up, okay, in the little yellow things are insulin secretion. So the yellow people are the insulin sensitive people, the people whose blood pressures went up when they ate a lot of salt. Insulins also went up when they ate a lot of salt. So just eating a lot of salt, if you're one of those people whose blood pressures go up with salt, you're going to secrete more insulin. And if secreting insulin is bad for you because it makes your beta cells wear out faster, it's really low insulins that we're shooting for, then this would be the kind of person that you would want to say, maybe it's the amount of salt that they're eating. And in our study, when we broke down whose blood pressures went up with salt and whose didn't, you could see that there was a significantly lower, significant more significant decrease in blood sugar levels and fructosamine levels in the salt-sensitive people on the paleo diet compared to the salt-resistant people on the paleo diet. So at least in our subjects, those people who had whose blood pressure went up the most were the ones that got the most better when we put them on this low-salt paleo diet. Tissue hypoxia. So tissue oxygen levels are one of those new things that people are talking about a lot today. And turns out that anesthesiologists do this all the time. They stick needles into people while you're asleep, and then they measure things like oxygen levels. And so fat people tend to have lower tissue oxygen levels compared to people who are not obese. And you can show that just having low tissue oxygen levels will both decrease your insulin sensitivity and lower how much glucose your cells take up, even in non-obese people. And oxygen is really important because oxygen is the final pathway for the main energy system inside the cell, which is called the mitochondrial electron transport chain. And so normally what happens is the oxygen finally accepts the electron, and then the system gets regenerated. But if you don't have enough oxygen in your tissues, then what happens is you have these backup pathways. And one backup pathway is the one that goes from pyruvate to lactate. So now you're making lactic acid. So you have extra acid in your system. And then the second one is one that uses the coenzyme Q and uses the so-called NADPH oxidoreductase pathway. And that causes these reactive oxygen species to accumulate. So what you see is when your tissues don't get enough oxygen, you're increasing both the amount of acids in the body as well as the amount of the reactive oxygen species, and both of those are bad. And we know that in people who have, like people with kidney failure who have metabolic acidosis, and rats, for example, we can show that all that acid directly affects how the insulin receptors and the IGF-1 receptors work. So actually, just having too much acid in your system makes your insulin receptors not work well. And similarly, we can show that oxidative stress affects those cellular pathways that happen after the insulin receptor is turned on, affects these intracellular pathways. And these do a lot of things depending on where the tissues are, and they're different depending on the different tissues. So they can affect glucose uptake in the muscles, and they can affect the amount of how much the blood vessel dilates, which is a really big deal in the heart and in the blood vessels in the body. Okay. And now let's talk about a little bit about free fatty acids. I've heard a couple of people talk about this today. So free fatty acids come from breaking down fat tissue. And in the liver, they increase the amount of glucose that's formed. And in the muscles, they prevent the insulin from being taken up. And so you make more glucose, you use less glucose, and the body's glucose levels go up. And turns out that people who are overweight or obese have higher free fatty acid levels, which then, as we said, leads to hyperglycemia. And just having high blood sugar levels in and of itself can cause toxicity. So, for example, it can cause the lenses in the eyes to become dense, so you can't see very well. It can actually alter how well the cells respond to insulin signaling. And it can cause more inflammation and higher levels of these so-called advanced glycosylation end products, which is where the glucose is attached to various other molecules in the body, and they accumulate, then they don't break down the way they should. And then secondarily, a lot of these people who are obese have this second problem, which is that the beta cells of the pancreas stop making enough insulin. So now, not only is your blood sugar level high, but your pancreas isn't making enough insulin. So there was this totally fascinating article in one of the kidney journals this past month. And I really thought, I have no idea if this is true or not, but this is really fascinating. So sevelamer is something that we give to bind phosphate in the gut. People with kidney failure have high phosphates, and that's bad for you. And so we give this sevelamer stuff. But these investigators gave it to people that they weren't trying to control their phosphate. They decided to look to see whether or not it would lower oxidative stress levels. And what they found was that not only, one, it lowered cholesterol and triglyceride levels. Like nobody has ever shown this before. Like giving this medication, which we use, it's not absorbed in the body, it stays in the gut, it's an ion exchange resin, and yet it lowered cholesterol and triglyceride levels in these diabetic patients with mild, moderate kidney disease. It also decreased the amount of these advanced glycosylation end products. It lowered oxidant levels. It increased antioxidant levels. So whatever it's doing, it's not doing it inside the body, it's doing it in the gut. And it made me wonder whether or not all the fiber that you eat in the Paleolithic diet might have some similar effect. Like somebody was talking about fructose and how fructose is bad for you. So we did a study in some of our patients, because our paleo diets were much higher in fructose than our ADA diets, and so we did a balance study to see what was happening inside the liver with the fructose that we were giving, and it turned out that there was no difference in what the liver was doing with the fructose between the paleo group and the ADA group. And so the diabetes guys that I work with began to think it was maybe because of the fiber in the gut, something, but maybe the fructose wasn't actually getting into the body, even though the diets themselves actually had more fructose in them. And so maybe this sevelamer stuff is doing the same thing that fiber is. I don't know, that's total. This is a really amazing study. I have to say I expect to see more from these investigators about this. So we decided to look at inflammation in our subjects. And for those of you who don't know very much about adiponectin, and I'm going to tell you I'm one of them, okay? So one thing that happens when you have a lot of inflammation is that something called IL-6, which is a cytokine, causes the liver to make something that's called CRP, which is C-reactive protein. And both of those are indicative of inflammation. When you have high adiponectin levels, okay, then supposedly that's going to cause the inflammation to decrease. And adiponectin is responsive to blood sugars. So as your blood sugars go down, your adiponectin levels are supposed to go up, and that's supposed to lower the amount of inflammation in the body. So that's what we expected to find. Instead, what we found was that both adiponectin and the supposedly active form high molecular weight adiponectin, both of those went down significantly. At the same time, IL-6 levels went up in both groups, and CRP went up in the ADA group and went down in the paleo group. But, okay, we had much lower blood sugars, okay? 20, 30 milligrams per deciliter lower on average than when they started. So we would have expected adiponectin levels to go up. Instead, they went way down. And then I got this slide from our next presenter, actually, where he was showing what are adiponectin levels in islanders who live off of Papua New Guinea compared to people in Sweden. And you can see that that's the Kitava, okay, had much lower adiponectin levels than Swedes of the same age did. So maybe it's not that the adiponectin levels went down that's important. Maybe it's that the adiponectin levels are low that's important, and that means that everybody else is adiponectin resistant, just like Dr. Rosedale was saying it. Yes, we're all insulin resistant, and I personally suspect we're all leptin resistant too. But it makes you ask, you know, what biomarkers should we measure? Should we measure leptin? Should we measure the relationship of leptin to the leptin receptor? Should we measure, is high molecular weight adiponectin the one to measure or not? Should we be, I don't know the answer to this, but it makes me wonder if we're measuring the right things. And then finally, how am I doing for time there? Okay. So finally, I read this other article about sleep and mice. And if those of you who went to see Gary Taub's lecture, so he was talking about is the fact that low carb, that you lose weight with calorie restriction. Is it really the calorie restriction? Is it just that you have less energy in or more energy out? Or is it because you're eating a low carb diet and your insulin levels are low? So what they did here was they gave the mice this new molecule that they've discovered, and it's called SR9011. And what it does is it makes the mouse's cells use more oxygen. So in Dr. Taub's equation, okay, that was the increased energy expenditure without the increased energy in. So the mice ate the same diet all the time, and then they got this SR9011 stuff. And when they did that, the mice lost weight, they lost fat. You can see over there when it says VO2, that's the one that shows that they're actually using more oxygen, so they're just expending more energy. And their glucose levels went down, and their insulin levels went down. And their leptin levels went down, and their IL-6 levels went down, so less inflammation, less leptin resistance, less insulin resistance, whatever. And all because you gave the mice these things which affected supposedly the activation system of the clock in our brain that controls like sleep, when we go to sleep and when we wake up. And so then I started looking at other studies where you look at what happens to leptin levels. So it turns out leptin is one of those things that it's highest in the middle of the night when you're asleep, and it's lowest in the middle of the afternoon. And leptin, for those of you who don't know, so leptin is one of those things that blocks the hunger chemicals in your brain, and it turns on the satiety chemicals in your brain so that you're not as hungry and you eat less. So if you have really high leptin levels, then you're not going to want to eat as much, and if you have low leptin levels, then you're going to be hungrier. So if you don't get enough sleep, then your leptin levels go down and you get hungry. And at the same time, it turns out that you're also become more insulin resistant. So lack of sleep is bad for you. But Dr. Lindeberg's group actually started looking at leptin levels and satiety, because if you're saying to yourself with the paleo diet, really it's just that I'm not as hungry and so I don't eat as many calories, then you would perhaps expect that what should happen is that leptin levels should go up. High leptin levels, not as hungry. Instead, what they found is that the people who are on the paleo diet, and that's in the open circles, so they actually felt fuller on a lower carbohydrate intake, but their leptin levels went down. So again, it makes me ask, like, our adiponectin levels went down, their leptin levels went down. Maybe the whole thing about having lower levels is correct, and that it does, when you're resistant to these hormones, then having lower levels is better, but if you're normal, having higher levels is better. I don't actually know the answer to this, but if leptin is one of those molecules that then promotes satiety and lower carb intakes and helps improve blood sugar and and perhaps is related to how we're sleeping, then perhaps just sleeping more might be something that might actually help you. So to review, I think tried to show that the paleo diet does improve insulin sensitivity, and my personal belief is that this is especially true in people who are more insulin resistant and perhaps salt sensitive, that if you had to concentrate on somebody to like you should do this diet, that would be the group I would choose. And so I think you can show that the paleo diet improves glucose control compared to other diets that we've used for diabetes. There's a variety of reasons why this might be true: genetics related to obesity, related to diabetes, related to satiety, related to sleep. I don't really know the answer to that. Anyway, thank you very much for your attention. These are my collaborators.
Hello, thank you
Hi.
for the talk. That was very nice. I wanted to ask a little bit more about your paleo diet intervention, because you mentioned that it was higher in fructose. And if I recall, correct me if I'm wrong, but a lot of the fructose was coming from juiced fruits and vegetables. Is that correct?
We served 3 servings of either like juice or vegetables. Yeah, 1 per meal. Right?
Mm-hmm. So, I mean, it seems to me that they must have been absorbing the fructose.
You know, I'm not going to say no to that. I'm going to say that we couldn't show that there was any difference in hepatic uptake or utilization of fructose between the 2 groups. And yet, even though the group that was, the paleo group, was eating more fructose, they had lower fructose levels. So
Lower
blood
fructose levels in the
blood.
blood?
Blood fructose levels and
Between
fructosamine levels, yeah.
Yeah.
So I don't know. I can only infer.
Yeah.
Yeah.
Okay, thanks.
Mhm.
Hello, Dr. Fresido. First of all, I want to thank you and congratulate you, because it's been 35 years since Eaton and Connor published their papers, and there have been only 5 controlled studies that have actually tested Paleolithic diet in controlled conditions. So I really thank you for that. Secondly, I want to put emphasis on certain suggestions given in this study. People are usually advised to follow a Paleolithic diet. They are not given any advice on macronutrient composition. There is all this talk about, low carb, high carb. The Paleolithic diet research doesn't need to get meddled up in this debate. The most important thing, now correct me if I'm wrong, I might be wrong here. The most important thing here in Paleolithic diet research is changing the sources of macronutrient composition. Instead of giving advice on high protein, low carb, low fat, when this diet regime started 35 years ago, based on that research, if you have read about this research, there was this paper published, plant and animal subsistence ratios. In that paper, and Dr. Ethan was a co-author of that paper. Lorraine Cordon was the primary author, and they came up with a range of numbers: 19 to 35% protein, 20 to 40% carbohydrates, and 28 to 58% fat. There is no suggestions from this research on how much carb, how much protein or fat we should consume. The most important thing is changing the sources of these macronutrients. So instead of deriving your energy from grains and dairy, you derive your energy from fruits, veggies, and lean meat, seafood, some nuts, and root vegetables. That's all that I wanted to say. And I wanted to say that now, because we have already had 2 talks on carbohydrates and starch, and now we have another 2 talks lined up on the actual studies that have been done on Paleolithic diet research. So I thought of bringing up this point.
Okay, thank you.
Thank you.
I mean, I actually have to say that, I think Dr. Eaton clearly showed that there's no one paleo diet. It really depended where on the planet you were from. So I'm sure that some people are eating lower carbs than others. Some people were not eating every day, and so they were intermittently ketotic. I think, there probably isn't one. There's probably a variety. And I actually agree with the person who got up here and said that it's more a question of where does it come from. Thank you.